Okay, this is equations. Involving logs and exponentials. All right. Now, the difficulty about this section is it requires that you are already good at the previous sections. Okay, maybe 4 or 5 sections worth. So the first thing that I'd like to do is review some of our rules and properties. What were some of the properties of logs we did last time? Can you give me one of them? Because if you don't know these properties, you won't be able to do today's material at all.
Log and AB.
All right, great. Log AB is equal to?
Log A plus B.
Great. Great. You need to know that. What's another one?
Log A over B.
Yes, log A over B. Great.
Log A.
And keep in mind, you need to be able to be comfortable going in both directions on these equations, okay? What's the next one?
Log A to the power n.
Power rule.
10.
Great.
And then
Okay, we don't have to worry about the change of base formula, but we do need to worry about just the regular log, writing a log as an exponential formula. How does that look? Let's say log base b of x equals y. How can I write that as in an exponential form?
B to the power of y.
Okay. Great. Let's add a couple more things that you need to know. Number one is, what's the domain and range on the log function? So this is from a few sections ago when we did the graph, right?
Yeah.
What's the domain and range on log? So again, you need to know what the graph looks like.
All the numbers
What's all real numbers?
on
No. All real numbers for the domain of the exponential, which meant all real numbers for the range. What's the domain of the log? Just the positive values, right?
yeah.
And that's important.
Can you write x is greater than or equal to 0?
Greater than 0, yeah.
Okay.
Now, a couple more things are going to come up, and I can add to this list as we go. But what's going to be crucial as we go through these problems is that you're able to see which rule we're utilizing in solving these things. Okay, let's get started. Log of x plus 2 equals 1. Here's my first equation. Okay, say you were given that problem and you were asked to solve it. If I'm asked to solve this, what does that mean, first of all? When you're asked to solve an equation, what are you solving for? What does that mean? Yeah, what is getting the solution, getting the answers? What does that mean, though? We're trying to find all numbers that we replace a variable by to make it true, right?
Mm-hmm.
It's a solution set. Oh, x could equal 0 and 5. It makes it true, right?
Mm-hmm.
So that's what we're trying to do. We're trying to find all the values that make this a true statement. Okay, looking at these things over here, what I would like to do is I would like to write this equation without log.
Yes.
Okay, is there one of these rules that allows me to do that?
The fourth one.
Yeah.
Yeah.
So let's write it in exponential form. Okay. So I need to know that. So how do I write this in exponential form? What's it going to look like? Well, what's the base of log?
10.
10. So 10 to the
First.
first equals
X plus 2.
x plus 2. Great. That's a big step, though, guys. If you don't have this memorized, then you're just going to be looking at this problem for 5 minutes and not know what to do. Okay?
Mm-hmm.
So it's essential that I'm like, oh, I know how to rewrite this in exponential form. Then I can get it to this. And this is something I can solve. Actually, it's something pretty easy to solve, right? This is probably like day 2 in our class.
Yep.
X plus 2 equals 10. What does x equal? What is it?
8.
Okay, but we're not done. Because with equations, we need to make sure that our solutions make sense. Okay? That's why I wrote this. The log only works with a domain that is positive values. Okay? So I have to make sure that if there's any logs up here, which there is, that this number is okay. What we're taking log of is going to be something in the domain. Okay? So I need to double check. If I plug in 8 here, 8 plus 2 is 10. Log of 10, that is something that we're allowed to take the log of, so it's okay. Versus, let's say x came out to be negative 12 or something, right? If I plug negative 12 in, you get log of negative 10, and that's not okay. That's not in the domain. And that would be an extraneous solution, okay? So log equals, x equals 8, that's my only answer. That's it, all right? But it relied on three things. Rewriting it in from log to exponential form, solving it with algebra, and then knowing the domain of the log function. All of these things that we've been working on come into play in this section, okay? Great, let's move on to another one.
Question.
Sure.
Would you got log of 1 because it equals to 1? Or 10 of the power to 1?
Yeah, 10 to any power equals 1, right?
Yeah.
So, I'm sorry, 10, so it was base 10, 10 to the first equals 10. Yeah. So you can always check these.
On our test, do we have to plug in the answer we get, value we get, to check it?
You should. And that's why I want you to get out your calculators, because we want to check these. Because some of these answers are going to look pretty crazy, so we want to be able to check them. We'll get to that in just a second. Okay? All right, next example. Looks so easy. 3 to the x equals 10. Okay. One of the great things about logs is when we have a variable as the exponent, when we use logs, we're able to pull that down based on this rule here, right? Bringing the exponent down, okay? So to solve an equation like this, what we're going to do is we're going to take log of both sides of the equation just so we can get that x to come down in front, okay? So to solve this problem, guys, what I would like you to do is take log of both sides, or ln of both sides, whatever you want. Okay? And the reason we take log of both sides is now I can bring that down here using my power rule, right? So now look what we have. We have x times log of 3 equals log of 10.
So that's it like that?
No, we have to solve for x, right?
Oh.
So x is being multiplied by log 3. So divide both sides by log 3. And we have x equals log 10 divided by log 3. What is log 10?
1.
1, right? Everybody know that? Why?
Because
10 to what power equals 10? 10 to the first. Okay, now again, this is kind of a crazy looking answer. So what I would like you to do is put it in your calculator, and then let's get an approximate value so we can test to see that is indeed the right answer. Okay, so plug in, and let's get an approximate number for this.
2.1.
Okay, so let's go out maybe, I don't know, 4 decimal places just to feel good. So this is approximately, if you put in your calculator, 2.0959. Does everybody see that? And why am I doing that? I want to check to see if the original answer is correct. So now go into your calculator and let's look at what 3 raised to the 2.0959 is. And it should be very, very close to 10. If it is, then we did it right. If not, something went wrong. Is everybody with me on that? So in your calculator, type 3 to the 2.0959, and what do you get? Should be super, super, super close to 10, right?
yeah.
And then we feel good about ourselves. Okay? So my answer is 1 over log 3. The approximate for that is 2.0959. How did I do this problem? I took log of both sides so I could get that variable down in front. Okay? This section's difficult, guys. We're just going to do a bunch of these equations relying on you knowing all of this stuff. Okay? All right. Let's keep going. That's why it's so important to know all of the previous sections to do this section. All right, here we go. Example 3. Log base 2 of x plus log base 2 of x minus 2 equals to 3. Okay, take a look at that one. Log base 2 of x plus log base 2 of x minus 2 equals to 3. Okay, let's take a little strategy here. I have log of something plus log of something. Everybody with me on that? Which one of these rules can I rewrite? The first one, I can rewrite that as a log of a product. And then I'll have a single log equal to something, and then I could go to here and write that as an exponential form. Okay? Did we kind of catch that? So step one, I have two logs. Let's write that as one log using property number one. Tell me how to rewrite that.
Log 2.
Log base 2 of?
X multiply x minus 2.
Great. And that is equal to?
3.
Everybody with me? That's property number one over there. The log of a product is the sum of the logs. Okay? Of course, I use it in this direction. Sum of the logs equals the log of a product. Now, I have this rule, right? Let's rewrite this in exponential form so I don't have the log sitting there anymore. So what's my next statement going to look like? 2 to the
Third power
equals?
x multiply x minus 2.
Great. This is an equation we spent a whole chapter on solving, right? Now you guys got to solve it. How do I solve x times x minus 2 equals 8? What type of equation is that? Quadratic, right? So I have 8 equals x, multiply this out for me, x squared minus 2x, right? How do I solve this? I bring everything to one side, I set equal to 0, and I try to factor it. If it doesn't factor, I use the quadratic formula. Okay? Spend a couple minutes, get that solved for me. It's just a quadratic equation. Solve it using all the methods we already know. Looks like it factors, so get it factored. How does it factor? X minus 4, x plus 2. Great. So I have two potential answers. What are my potential answers? Negative 2 and 4. Do both of those answers work?
You don't know until we put it in.
Yeah, if I plug in x equals negative 2 right there, is that going to cause a problem?
Yes.
Absolutely. Why? What's the domain of the log? Positives. Can't put in negatives. Negative 2 does not work based on that alone. Okay? Is 4 okay in both of these? Yes. So I have one answer, just x equals 4. How many things did I have to know to solve this problem? A lot. Right? I had to use my first property of logs over there. I had to use my fourth property of logs over there. I had to know how to solve equations by quadratic, in quadratic form. In this case, we were lucky it factored. Then I needed to know what the domain of log is to check which ones were extraneous. It's like 5 things you had to know to solve this equation. And that's what's expected of you in this section, okay? These are not easy. If you can't even do, if you're looking at this problem and you don't know this rule, it's going to be a long section for you, right? So you have to know these rules. You have to memorize those, okay? Is everybody okay with this? So x equals 4 is my answer. Just one answer. Okay. Let me give you one. See how you guys do. I'll give you one very similar to this one. See how it goes. Log of 3 minus log of x minus 1 equals to negative 1. All right, take a few minutes. Get that solved for me. Okay, which formula did you use first to write it as a single log? Number 2, right? Log of what? 3 over x minus 1 equals to negative 1. Right? The log of a difference is the quotient of the log. That should have been the first step. Step number 2, can I rewrite it using this? Write it into exponential form. What's the base here? 10. 10 to the negative 1 equals 3 over x minus 1. Okay? That relies you knowing what 10 to the negative 1 means. What does that mean?
Fraction.
Yeah, 1 over
10.
1 over 10. Great. Now, this was a few sections, a few chapters ago. If I have a fraction equals to a fraction, how do I solve something like that? Cross multiply, sure. So I have x minus 1 times 1 equals 10 times 3, which is 30. It's a pretty easy equation to solve. X minus 1 equals 30. What does x have to be? Add 1 to both sides. 31. Okay, is 31 okay if I plug it back up here? Yeah, it's a positive, right? So my answer is x equals 31. Again, I need to know 5 things to be able to do this, though.
Are we still allowed to have a card on our test?
Yes.
Including the final?
It'll get bigger for the final.
How?
Like a half sheet or something. Not huge.
That's good.
All right, now let's get into the really difficult ones. It's going to take a couple days to get through this section because of problems like this. 2 to the x equals 3 to the x minus 1. All right, number 1. Notice I have a variable as an exponent in both of these, right? So I'm going to have to apply log to both sides just so I can bring that exponent down, okay? So my first step is I'm going to take log of 2 to the x equals log of 3 to the x minus 1. And the only reason why I did that is so I can bring those variables down, okay? Using this power rule right here. Again, you guys have to memorize these, right? These things are going to carry you through this section. X times log 2 equals x minus 1 times log 3. Now, unfortunately, because I have x minus 1 here, this is more than one term, right? So this, x goes with log 3 and 1 goes with log 3. It's a distribute, okay? So go ahead and distribute out the right side there. We have x log 2 equals x log 3 minus log 3. Okay, so let me stop for a second. The first thing I did is because I have both of these variables in exponents, I took log of both sides. Once I did log of both sides, both of the variables dropped in front, right? The powers dropped in front. But this is more than one term. So this is a distribute, x times log 3 and minus 1 times log 3. It's 2 terms, okay? Now, keep in mind what I'm trying to do overall is I'm trying to solve for x. X right now is in 2 spots, okay? So I'm going to take these and bring them over together on one side by itself. So I have x log 2 minus x log 3 equals negative log 3. Okay? Now that I have these x's together, I'm going to factor an x out. All right? So you factor an x out front, and what's going to go in the parentheses, factoring an x out? Log 2 minus log 3. And that is equal to negative log 3. Now I have x times something equals something, but I just want x equals. So how do I undo multiplication? Divide. So even though this is a really ugly looking thing, I need to divide by that whole thing. Okay? So now divide both sides by log 2 minus log 3. Okay, guys. So right now I have x equals negative log 3 divided by log 2 minus log 3. How confident am I of that answer? Not really. All right? It looks pretty ugly, in all honesty. Okay? So what I'd like you to do now is take out your calculator, get an approximate for this, and let's go back to the very top and check to see. If it works out, then great. I'll feel really confident about my answer. Okay? So be careful. Make sure you have parentheses on the bottom because this whole thing is in the denominator. All right? So take out your calculators. Let's plug in negative log 3 divided by parentheses. Make sure you put this bottom log in parentheses. Log 2 minus log 3, and close that extra set of parentheses for the bottom. And I'm getting, if I go 4 decimal places, approximately 2.7095. Make sure you guys all get 2.7095 approximately. Okay? And then what I'm going to do is I'm going to use my calculator to check I'm going to plug 2.7095 right there and 2.7095 right there to check to see if it works. Okay? Okay, so let's plug in. Let's go to our calculator. Let's check now. Let's plug in 2 raised to the 2.7095. See what that is? And then let's plug 3. 2.7095 minus 1 is 1.7095. So let's look at what these equal, and they should equal each other for us to be correct. Okay? So plug in 2 raised to the 2.7095. Comes out to be about 6.54 something, right? Roughly 6.54 something. And let's look at 3 raised to the 1.7095. Comes out to be 6.54 something. That makes me feel good. So I know my answer checks out. And this answer of negative log 3 divided by log 2 minus log 3 is the correct answer. So everybody with me on what I did there? A lot of things happening. Let's just do another one. All right, let's try another one. Let's solve it and then check it.
So any of these rounded to four decimal places?
Yeah, I just want to go up 4 decimal places just to give it a good check. Yeah.
Okay.
Yeah. Okay, guys. I'm going to give you a few minutes to see how far you can get on this one. 6 raised to the x minus 3 equals 2 to the x. Solve that and then check it. 6 to the x minus 3 equals 2 to the x. Solve it and then we'll check it. All right, let's take a look together. Log of both sides first, right? Then I could bring down the numbers in front. X minus 3 log of 6 equals x log of 2. Then I distribute here. X log 6 minus 3 log 6 equals x log 2. Now, look at where x is, here and here. I got to get those x's together on one side and move the thing without x on the other side. Okay? So that's my next step. There's 2 ways to do that. I could bring this x over and move the 3 over here, or I could just move the x over here, right? Either way, you're going to get the same answer when we go to the end and approximate it, okay? So I'm just going to leave stuff over here. I'll move the 3 over and move this x over. So I'm going to do x log 6.
Question? I
Yes?
thought you multiplied it with 6. When you distribute the 3, wouldn't you multiply it? Not.
Yeah, so I distribute x to log 6, which is
Yeah.
x log 6, and then negative 3 log 6, which just puts the 3 in front.
Oh, okay.
Yeah. So what you said is correct, and this is how you multiply it.
Oh, okay.
Yeah. X log 6 minus x log 2 equals 3 log 6. Then factor out an x. There's an x in both of these. Factor it out. Log 6 minus log 2 equals 3 log 2. I'm sorry, 3 log 6. Okay. Dividing both sides by this big chunk here, and we get x equals 3 log 6 divided by log 6 minus log 2. Okay, guys, go to your calculator and approximate this for me, please. Let's go 4 decimal places. Put this in parentheses. Let's do that. Approximate. What'd you guys get? 4 decimal places. 4.8992, and I'm going to bump that 7 to an 8 just because the next number is a little higher. So about 4.8928. What do I do with that 4.8928? Plug it in right here and plug it in right here to see if these are approximately equal to each other. Okay? So 6 to this minus 3, so 6 to the 1.8928. See what that comes out to, and then check what 2 to the 4.8928 comes out to. And these numbers should be the same if I did this right. Okay? So 6 to the 1.8928 comes out to about 29.70 something. And 2 raised to the 4.8928 comes out to 29.70 something. They're both 708 something. That makes me feel good, because that means this answer is correct. Questions on this? Yes?
When we put our answer on like the test or something, do you want the approximated answer or the...
I want the exact answer, and I want to see the approximated answer. Both. Okay? Okay. Then, these are the more difficult ones. But I want to add a couple more things to our list over there, and I call these common sense laws. So let's add a couple more things. While you guys are doing homework and quizzes and stuff, you might come across some of these common sense ones. If you have a to some power equals a to some power, they both have the same base, then the only way that this is going to be true, a to some power equal a to some power, then the only way that this is going to be true is if those powers equal to each other. Okay? Then x equals y. Similarly, if I have log to some base of something is equal to log of some base of something, then these somethings have to be equal. Okay? So if I just put a big X and a Y, then X equals Y. And so, for example, let's do a couple examples. Log of 2x minus 2 equals log of 14. When you have a problem like this, you can just use your common sense laws here. Log of something equal to log of something. Well, the only way that these are going to be equal is if those somethings are equal. Is everybody with me on that? Log of this equals to log of this. Well, then 2x minus 2 has to equal to 14. Okay. And then I can solve that pretty easy. What do I get? Add 2 to both sides. X equals 8. And then I just need to make sure that it's still in the domain, right? You always have to check domain. If I plug in 8 up here, it's going to be positive, so it's okay. So that works. Okay. Great. And then last example. If I have 5 to the x, 5 to the x plus 2 equals 5 to the 15th. Again, 5 to some power equals 5 to some power. The only way that these are going to be equal is if the powers are equal to each other. Mm-hmm. Okay? It's a common sense law. So what does x equal? 13. Is it okay to have negatives in exponents? Yes. Just not log. The domain of log you can't have. Well, I mean, actually, be careful what I said there. The answer itself, x could equal negative, but when I plug it into here, I got to make sure that log of whatever I'm doing is not negative. Does that make sense? In exponentials, you can have negatives and positives in the domain of exponential. Okay. This is like a 2-day lecture, so we'll do more next time, but it's difficult, guys. You need to, those things that I erased over here, you have to know those very, very well, because you're going to be applying them back and forth to do the equations today. Okay? All right. Test is when? May 6th.